Okay, now in this video we're going to talk about the different types of variables in Solidity. Solidity is a statically typed language, which means the type of each variable needs to be specified. The most important value types that you should remember are booleans, integers, address, bytes, string, hex, and enum. Booleans, as you may know, are data types that may have only two possible values, true or false. In Solidity they are defined with the keyword bool. The integers in Solidity, however, are a little bit more interesting. If you don't know, an integer is a number with no fractional part. It can be positive, negative, or 0. Here they are defined in bits from 8 to 256 and can be signed and unsigned. Signed can be positive and negative value. As for unsigned, they are only positive numbers inside. In Solidity, we don't have decimal or floating numbers for now. Fixed point numbers are defined in the documentation as a way to define decimal numbers, however with a big warning sign that says that they are not fully supported yet. So for now, we don't have decimal values, but keep in mind that in the future this might change. Now, the address type holds 20 byte value, which is the size of an Ethereum address. Addresses also have members and serve as a base of all contracts. We also have string types, which are written with either double or single quotes and can hold text. Hex types hold hexadecimal strings, and enum values are the ones that create user-defined types in Solidity. Now let's see the integer types in more detail. Integers, as I said, can be signed and unsigned. Signed integers are defined with the keyword int and unsigned with the keyword uint. The integers are defined in bits of 8 to 256 with the step of 8. So 8, 16, 32 and so on. Here in this table you can see the minimum and maximum values of each integer. Keep in mind that if you define integers without the numbers at the end, only with uint or int, those are aliases for uint 256 and int 256 respectively. You're responsible for best optimizing your code, so use the corresponding sizes according to your needs. It's your own decision whether you use uint 8 or uint 256 or whatever size, depending on how big or small you expect the number in question to be. So with integers, you can do comparison, bit and arithmetic operations as listed below in this table. Just keep in mind that as in any other programming language, you can have overflow or underflow of a number. For example, if you define a uint 256 equal to 0 and then you subtract 1 from that number, you will get this large number over here. This can cause a lot of trouble, so be aware of it. The next variable that we're going to discuss is the address variable. For each address variable we have the following members. We have balance, which gives us the balance of the address in way. We have transfer, that can send a given amount of way to an address, and we also have the member send, which does the same. However, the difference here is that the transfer throws an error if it fails, and send returns false if it fails. Otherwise, both do the same thing. We also have code, and delegate code, which are low-level calls. We're going to skip on what those address members do for the moment, but just keep in mind that they exist. We also have bytes, which are the binary representation of data. As you can see, we can have fixed size bytes from byte 1 to byte 32. They store 1 to 32 bytes of data respectively. We would want to use bytes over strings whenever we want to optimize our contracts to be cost efficient. Usually, working with strings instead of bytes will take up a little bit more gas when running a function. Second reason to use bytes over strings is smart contracts to smart contracts relations. Solidity is still unable to return strings as a function result for other contracts. It may look like really unnecessary stuff to know, but smart contracts are getting complex with each day, and the further it goes, the more contract-to-contract relations are going to appear on the blockchain. And last, we're going to see the strings, hex, and enums. Strings are a sequence of characters that are written in either double or single quotes, like in this example. Hexadecimal literals are prefixed with the keyword hex and are enclosed in double or single quotes, and are saved in byte variables. And last, there are enums, which are user-defined types in Solidity. As you can see in this example, you can create enum code action choices with go left, go right, go straight, and sit still. You should always use enums when a variable can only take one out of a small set of possible values, like in this example. Okay, so now you know the basic types in Solidity. Let's continue to the next lecture to have some practice in Remix again.